So far we have studied that charges are of two types, positive and negative, and the fundamental particles electrons and protons have this property. Electron has negative charge, proton has positive charge, and these are equal. And how much this charge is? 1.6 into 10 raised to the power minus 19 Coulomb, plus minus. Plus charge is on proton, minus charge on electron. And I told you that plus and minus doesn't mean that lesser or more. It is just of opposite type. So one proton, one electron, if we combine this charge, this will neutralize. That's the meaning of positive and negative charges. Like charges, it is positive positive or negative negative, they repel. Unlike charges, like plus and minus, they will attract. Now, in this topic, we will do Coulomb's law. Coulomb's law tells us about the force between plus and minus. Coulomb was a French physicist who quantified actually the force between the charges. So plus plus, plus minus, or minus minus, if we take two charges, Q1 and Q2, they may be plus, minus, whatever. Then the force between the point charges, 2 point charges, the force between them is proportional to the product of charges and inversely proportional to the square of the distance between them. It is just like, if you can recall, just like the law of gravitation, where the force is proportional to the product of masses, inversely proportional to the square of the distance. But here we had this constant, which is a universal constant, universal gravitational constant, which means that this constant doesn't depend on anything. It is always constant. Here there is a difference. When we remove this proportionality sign, we have a constant which depends on the system of units that we are taking, and it also depends on the medium. So if we take SI units, International System of Units, then this is the force between 2 point charges Q1, Q2 separated by a distance R. Here, this is the constant of proportionality, 1 upon 4 pi. This is called epsilon naught or epsilon 0. And this is called permittivity of free space. Permittivity of free space. If we are taking vacuum, and even for practical purposes, even for air we take this expression, this only, but if we are taking any other medium, then this constant is different. F is 1 upon 4 pi epsilon naught Q1 Q2 by R square. This is when we are talking about vacuum. But if we take any other medium, then this becomes 1 upon 4 pi epsilon Q1 Q2 by R square. Now here this constant is the permittivity of the medium. We shall do it in other classes, this constant is actually related to the polarizability of the medium. Different substances are polarized to different extent, and the force between any 2 point charges depends on that. That's why it depends on the medium. And this permittivity of the medium actually is the permittivity of free space multiplied by relative permittivity, or another name of it, dielectric constant. So it is dielectric constant or relative permittivity. This is the permittivity of the medium. Epsilon is epsilon naught times this. Permittivity of the medium, permittivity of free space. And epsilon r is taken 1 for vacuum, and even for air we take it 1. It is slightly more than 1 actually. And it is around 80 for water, and for all other mediums it is actually more than 1. For all other mediums, which simply means that the maximum force between 2 point charges is when they are separated, when they are kept in free space. So most of the time, unless until it is mentioned that we have some different medium, I will assume it as air or vacuum, and Coulomb's law will be written as 1 upon 4 pi epsilon naught q1 q2 by r square. Now the value of this constant, it is 9 into 10 raised to the power 9 Newton meter square per Coulomb square in SI system. And epsilon naught we can find out from here, it is 8.85 into 10 raised to the power minus 12 Coulomb Newton meter square. We can find out using it epsilon naught 4 pi, substitute these values, we can have epsilon naught. So the permittivity of free space is 8.85 into 10 raised to the power minus 12. So again, the Coulomb's law is the electrostatic force between 2 point charges is proportional to the product of charges and inversely proportional to the square of the distance. This is Coulomb's law. When we are writing the expression, this constant of proportionality is 1 upon 4 pi epsilon naught. This depends on the system of units that we are taking, and it depends on the medium actually. In SI system, this value has been taken as 9 into 10 raised to the power 9. This is called the permittivity of free space. If there is any other medium, this is replaced by epsilon naught, epsilon r, which is called relative permittivity or dielectric constant. And epsilon is the permittivity of the medium. Okay, so this is the force between 2 point charges q1, q2 separated by a distance r. Now, let us see how this force acts. If it is attractive, it is along this line. If it is repulsive, it is along this line. What does it mean? What it tells about the direction? Two things. Firstly, the force on, if I represented force on first due to second, force on second due to 1, force on first due to 2, force on second due to 1. In these cases, in the first case, force is this force is this. Opposite in direction. Here also opposite in direction. So force on first particle due to second is always equal to force on tube due to 1, but opposite in direction. So it means Newton's third law is obeyed here too, and it should be actually, right? So whatever force acts on first particle, second particle also experiences same force but in different direction. Another important characteristic of this force is that this force is acting along the line joining the two charges. See, it is along this line. Such forces are called central forces. So electrostatic force is a central force. It means it acts along the line joining the two charges. Not all forces are central. Okay. Gravitational force also central force, and gravitational force also obeys Newton's third law. But there is one difference between gravitational force and this. Gravitational force is always attractive, while electrostatic force may be attractive as well as repulsive. So this is Coulomb's law, 1 by 4 pi epsilon naught q1 q2 by r square. Force is central force and on both the charges. So this is the force on this and this is the force also on this. Now how can we write it in vector form? That's again very important because force is a vector quantity. So if I take two vectors, q1 and q2, described by vectors r1 and r2. It means r1 is the distance of q1 from the origin and r2 is the distance of this. So vectors representing these two, r1 vector and r2 vectors. I want the force on q1. So force on q1 will be force on 1 due to 2, 1 upon 4 pi epsilon naught q1 q2 by what is the distance of this from this. See, distance of q1 from origin is r1 minus 0. Distance of q2 from this is r2 minus 0. So what is the distance of q1 from q2? Actually it will be r1 minus r2. If we are calculating distance of any point with respect to another one, what do? We subtract that coordinate. If I ask what is the distance of 5 from 3, it is 5 minus 3. Here I am saying what is the distance of q1 from q2, so it is r1 minus r2. What is the distance of 100 from 98? It's 2. So r1 minus r2 square. But if I am writing the vector form, force is a vector quantity and right hand side so far is scalar. So I need to multiply it by, this is the force acting, if it is repulsive in this direction, attractive in this direction. So I need to give a direction to this force. How do we? This is the magnitude of this force and I need to give a direction. Whenever we have magnitude and we want to give direction to it, how? We multiply it by a unit vector. So I need a unit vector for q1 with respect to q2. It is r1 minus r2 divided by r1 minus r2. How do we find any unit vector? It is vector multiplied its magnitude. r1 minus r2 tells me where q1 is with respect to q2. And what will be its unit vector then? Unit vector in this direction, r1 minus r2 divided it by. So I can write r1 minus r2 here upon r1 minus r2 magnitude. So now F1 on 2 will be 1 by 4 pi epsilon naught q1 q2 r1 minus r2 divided by r1 minus r2 q. But again, one very important thing to be kept in mind is this is the force on 1 due to 2 and it is coming here q. So don't take it as if force is inversely proportional to distance q, because one distance is here also. So still, what is the dimension of this term? It is 1 by meter square. So F is inversely proportional to even now distance square. This is the force on 1 due to 2. If I want force on 2 due to 1, what will be the difference? Q1, Q2. The only difference is R1, I want 2. So R2 minus R1 divided by R2 minus R1 Q. What's the difference? Here it is R1 minus R2 and here it is R1, R2 minus R1. So F12 is minus F21. Here it doesn't matter whether denominator I write it R1 minus R2 cube or R2 minus R1 because it is the mod. So it always remains positive. But numerator makes a difference here because it is the difference of two vectors. So R1 minus R2 is not actually R2 minus R1. There will be a minus sign. So this is how we can write Coulomb's law in its vector form. Force 1 upon 4 pi epsilon naught Q1 Q2 by R square. Square of this distance multiplied by unit vector for this, and unit vector is R1 minus R2 upon R1 minus R2. I can also write it R12 cap. Anyway, this is. Now what if I have many forces? Principle of superposition. What does it mean? Suppose I have Q, then I have Q1, Q2, Q3, Q4, so many vectors and their so many charges with their vectors as R1, R2, R3, R4 and so on. I want force on Q due to all other charges. This is by applying principle of superposition. Superposition term itself makes it clear. Superposition means we have many things which are to be superposed or added. So what is superposed here? The force on Q due to Q1 we can calculate by using Coulomb's law. Force on Q due to Q2 again we can calculate. Due to Q1 it will be 1 upon 4 pi epsilon naught Q1 into R minus R1 vector divided by R minus R1 mod Q. Same way force between Q and Q2, Q and Q3, Q and Q4 and so on. If I give you more charges. Principle of superposition says that the force between Q and Q1 will not be affected by the force between Q and Q2, Q and Q3. So the force on any one charged particle due to any other charged particle is independent of the force on the same charged particle due to many other charges. But to find out the resultant on this, we need to take a vector sum. So we need force on Q. It will be the vector sum of force on Q due to Q1 plus force on this due to Q2 plus force on 3 due to 3 and so on. Okay. So it will be 1 upon 4 pi epsilon naught Q1 R minus R1 upon R minus R1 Q plus Q2 R minus R2 upon R minus R2 Q and so on. So force on any one charged particle is just the vector sum of forces acting on this charge because of many other charges. 1 upon 4 pi epsilon. I can write it in some other convenient and short form by using sigma. Q is common, so I can write it here. And now I can apply sigma. Q I, because I am getting Q1, Q2, Q3, let me write it Qi, I is where it is from. R minus Ri divided by R minus Ri cube. So this is the force due to all these particles on Q. And in this particular case, I can say, because there are 4 particles, so I can write I from 1 to 4. For this particular case, if there are n charged particles, so this will be the general expression. F is q upon 4 pi epsilon naught summation qi r minus ri upon this. So what we have done today, Coulomb's law, which tells about the force, electrostatic force between 2 point charges. F is 1 upon 4 pi epsilon naught q1 q2 by r square. This force depends on the medium. So if I take any other medium, this becomes 1 upon 4 pi epsilon naught into epsilon r, where epsilon r is called relative permittivity or dielectric constant. So that is the force between 2 point charges. The value of 1 upon 4 pi epsilon naught is 9 into 10 raised to the power 9. Then I told you how to write it in vector form. So q1 with respect to q2, r1 minus r2 divided by r1 minus r2 mod, that will give me the unit vector for this, multiplied the mod of the force by this, so it becomes 1 upon 4 pi epsilon naught q1 q2 r1 minus r2 upon r1 minus r2 q, force on q1 due to q2. The same is the force on 2 due to 1, but opposite in direction. Principle of superposition, it is just the vector sum. Force on any one charged particle is the vector sum of all the forces on that charged particle because of many other charged particles. So that is the principle of superposition. So that's it for this class. We'll take up the electric field in the next class.